In our applications today, we're going to start by talking about puzzle problems. On all of these puzzle problems, I'd like you to show the equation for full credit. First thing that I want to talk about is how you deal with the phrase consecutive integers and consecutive even and odd integers. So first off, what does this mean? Consecutive integers. Well, let's say we're talking about three consecutive integers, like 6, 7, and 8, or 3, 4, and 5. That's a 4. Or -4, -3, and -2. Now let's talk about how would you make expressions to talk about each one of these situations. So first of all, let's call our first number n. How would we then name our second and third numbers in terms of n? Well, look at the first numbers. It's the 6, the 3, the -4. What happens in between these? It's from 6 to 7, from 3 to 4, from -4 to -3. You're adding 1, right? So if the first number is n, then the second number must be n plus 1. And how are you getting, look at the 6 compared to the 8, and the 3 compared to the 5, and the -4 compared to the -2. You're always adding 2. So the third, a good name for that third number would be n plus 2. So the names of consecutive integers are n, n plus 1, n plus 2, n plus 3, n plus 4, and so on. The same thing kind of holds for consecutive even or consecutive odd integers. If we name our first number n, let's think about what our second and third integers are going to have to be named. Now first, let's list some even and odd integers. Okay, so let's say even integers, consecutive even integers. Here's an example, 8, 10, 12. Here's another example, -4, -2, 0. How about consecutive odd integers? 3, 5, and 7. Now think about the relationship. If the first one is 8, how does that relate to the second one? If the first one is 3, how does that relate to the second one? You're adding 2 on, right? To get from the first even integer to the second even integer. So the second number is going to have the name n plus 2. Now it doesn't even matter if it's even numbers or odd numbers, you still add 2 to get to that next number in line. The same thing for the third integer. If the first one is named n, the third one is named n plus 4. Doesn't matter if they're even or odd. If the first one is n, that third one will be 4 more than that, so n plus 4. So if you're asked to find consecutive even integers or consecutive odd integers, the names of them would be n, n plus 2, and n plus 4. Let's start with one that's not quite so tricky. 6 less than a number is 7. Remember, is means equals. So we should be able to make an equation out of this. 6 less than a number. Remember, 6 less than a number means n minus 6 is equals 7. So now let's just solve for n. Undo what's been done to the n. The number is 13. Let's do another one. 8 less than 3 times a number is 4. So instead of a number, I'm going to put n, and instead of is, I'm going to put equals. So 8 less than 3 times a number is 4. So I make an algebraic equation out of it. Now I can just solve. I need to undo what's been done to the n. So n, or my number, is 4. A 12-yard fishing line is cut into 2 pieces. 3 times the length of the longer piece is 4 times the length of the shorter piece. Find the length of each piece. First, we have to name each of the pieces. Let's call the short piece X. What do we know about those 2 pieces? Well, we know that they add together to be 14 yards long. So then, how could we name the shorter piece? How could we name the longer piece? Well, if the short piece is X, how would you get the long piece? You'd take 14 minus X. So anytime we say short, we're going to say X. Anytime we say long, say 14 minus X. Now let's make this sentence into an equation. 3 times the longer piece, okay? 3 times the longer piece is 4 times the shorter piece. 4 times the shorter piece. Now that we have our equation, all we have to do is solve. So let's see. I'll need to distribute. I can't add like terms, but I do need to get my x's all on one side. So I'm going to move this negative 3x over here by adding it to both sides. And then undo what's been done to the x. So to undo multiplying by 7, you divide by 7. So x equals 6. My short piece is 6. My long piece is 14 minus 6, or 8. So there are my 2 pieces. Find 3 consecutive odd integers whose sum is 33. The first thing we have to do is name each of our integers. Just like I talked about earlier in the lesson, name the first one n. So then since they're odd, they're going to be separated by 2 numbers, or 2 units. So if the first one's n, then the second one will be n plus 2. And the third one will be n plus 4. It's just like I talked about earlier in the lesson. So now we know that their sum is negative 33. So that means if you added the first plus the second plus the third, you would get negative 33. So let's just put our numbers in there. The first is named n. The second is named n plus 2. The third is named n plus 4. And adding all those together will give us negative 33. So now let's just solve. I can add my like terms on the left side. So let's see, I have 1n plus 1n plus 1n, that's 3n. And then a plus 2 and a plus 4 makes a plus 6. 3n plus 6 equals negative 33. Now let's just solve for n. Undo what's been done to the n. Minus 6 from both sides. Divide by 3 on both sides. N equals negative 39 divided by 3, which is negative 13. So n, the first integer, is negative 13. The second one will be 2 more than that, negative 11. And the third one will be 4 more than the original, or 2 more than this one, -9. Those are our 3 integers. If you're starting to get these, pause the video, do the last 2 problems on this page, restart the video, and check your answer. If not, keep watching. Find 3 consecutive even integers such that 3 times the second is 4 more than the sum of the first and the third. Let's unpack this a little. First, name your 3 unknowns. We are looking for 3 consecutive even integers. So let's name the first one n. Since they're even, they're going to be 2 apart. So that means the second one is going to be n plus 2. And the third one will be n plus 4. Now let's use this sentence to make an algebraic equation. 3 times the second. Second is n plus 2, so 3 times n plus 2 is equals 4 more than is 4 plus the sum of, that means add, the first and the third. So add together the first and the third, n plus 4. Now, let's simplify this. First, we can distribute. Next, add like terms. Well, over here, 3n plus 6, that cannot be added together. Those are not like terms. So let's look at the right side of our equation. We have n and an n, that's 2n. And 4 plus 4 is 8, so 2n plus 8. Then let's get rid of n's on both sides. So subtract 3n from both sides. You can also subtract 2n from both sides. Then undo what's been done to n. Divide both sides by -1 to get rid of that negative n. -2 divided by -1 is 2. So I know that n, or my first number, was 2. The second number will be 2 more than that, or 4. And the third number will be 4 more than the original, or 2 more than this one, 6. My consecutive even integers are 2, 4, and 6. We have a smaller number and a larger number. Let's name our smaller number x. Then our larger number, how can we name that? Well, the 2 numbers total to be 18. So if the first one's x, the second one is 18 minus x. Now let's use that to make an equation. The total of, so that means add, 3 times the smaller, 3 times x, and twice the larger, so 2 times the larger, 2 times 18 minus x, equals 44. There's our equation. Now we can solve that equation. Pause the video if you need time to write this down. And you find that x equals 8. So that means my first number, the smaller number, is 8. So my larger number must be 18 minus 8, or 10.